Hi, everyone. Thanks for tuning in again. I just start by introducing myself. So I'm John Adiojo, founder and chief data scientist at Data-Centric Solutions. This will be a short video today, and I just wanted to get into something that I've seen a lot. So this is why you can't use Llama 2. Now, I've seen a lot of videos, especially given the popularity of a lot of the open source foundation models, where they're experimenting with these models. You've got hobbyists, independent researchers, engineers playing around with these open source models, and they can't get beyond the, they can't get beyond the 7 billion parameter models, or the smallest scale of those open source models. And sometimes it's not clear that they understand why they can't get beyond those models. They can't run them locally. They can't experiment with them. They can't even test them out on the Hugging Face platform. So hopefully by the end of this video today, you'll understand why that is, that it's so difficult to use these models locally. And also I'll talk a bit about a solution to that problem that is on the horizon. There's an open source project that is trying to democratize access to these larger foundation models. So let's get into it. So if you've been anywhere near the AI community, or you've had any interest in AI, you'll know that there have been a lot of foundation models to come out into the public domain recently. Just to name a few that have come out over the last couple of months, we have seen Llama 2, the largest of which has 70 billion parameters. If you take a look on screen, I've got a model card for that open now. As well as Llama 2, there is also Falcon that came out, and I think the largest model for Falcon is 40 billion parameters, and there's Bloom, which has over 100 billion parameters. Now, you cannot use any of these models, most probably, and I will get into why that is. So why can't you use any of these models? Take a look at this, training it at scale, right? So hopefully you can see what's on screen here. Just bear in mind, let's take Llama 2, for example. Let's look at the 70 billion parameter model. So for each parameter in that model, right, it's stored in a level of precision that we call, like, it's 32-bit precision. So, you know, if you've programmed before, you'll know that you can store floats at 32 bits. If you are loading the Llama 2 model at 32-bit precision, then it's going to cost you 4 gigabytes in memory per 1 billion parameters. 4 gigabytes in memory per 1 billion parameters at the 32-bit precision, which is usually the standard level of precision that you load a model at. Right, just keep that figure in mind. There are options to load the models at lower levels of precision. So you can go to 16, you can go to 8. There, I have seen things that you can go down to as low as 4 bits, but for all kind of practical intents, I think 8-bit is probably the most practical you can go in terms of precision reduction, right? So at the 4-bit, at the 8-bit precision, it's going to cost you, in GPU usage, it's going to cost you 1 gigabyte per billion parameters. All right, so let's just do the math on that, right? So we've got a range here. If you are storing at the 32-bit precision, you're going to have to use 280 gigabytes of memory, of GPU memory, just to load the model. Just think about that and remember that figure. Hold that in mind. I'll link to this article because I think it's useful to try and understand these concepts. But you are going to have to use 280 gigabytes of memory just to load the Llama 2 model at 70 billion parameters in 32-bit precision. If you go down to 8-bit, you're going to have to use 70 gigabytes of GPU memory. And we're just talking about loading the model here. We're not talking about fine tuning or doing anything. This is just loading for inference purposes. Right. If we move on to fine tuning, so if we're fine tuning with an optimizer, it is approximately 8 bytes of GPU memory per parameter. So that's for the fine tuning processes. Once you've loaded the model, you want to fine tune it on a downstream task. What would this mean for Llama 2? So for Llama 2, this would be the equivalent of 560 gigabytes of GPU memory to fine tune that model. So that's in addition to loading. Okay, so what's the total memory cost for loading Llama 2 and fine tuning it? Let's say if you wanted to do something downstream. So you're looking at between 630 gigabytes to 840 gigabytes. And that's obviously depending on the lower ranges if you're loading in 8-bit precision, and the higher end is if you're loading in 32-bit precision. Right, so hopefully I think this should start to make a little bit more sense as to why you cannot use Llama 2. You cannot use Llama 2, I'll repeat. Okay. For most data scientists, engineers, hobbyists, independent researchers, I would guess that most don't have GPUs in their laptops. I would guess that most of the time, your access to GPUs either comes via the cloud or you use a service like Google Colab to get access to a GPU. So I happen to have an MSI laptop. It's a gaming laptop. I don't play any games, but I bought this a few years back because I wanted a powerful laptop with a GPU to be able to create some of my deep learning projects. I wanted to be able to train models locally. I'm just going to pull up the specs for my laptop to give you an idea of what we're looking at here. So hopefully you can see what's on screen. But I have an NVIDIA, what have I got? I've got an NVIDIA GeForce RTX 2060. And just have a look for a second at the memory here. This is just under 6.5 gigabytes of memory, of GPU memory. Now, what did we say? The range to just load a model, we're talking about between 70 gigabytes and 280. So this is a warning. Don't go out and buy an expensive gaming laptop just to run your large language models. I don't know how many of you would do that, but it's a waste of money. You're probably not going to get the spec you need. These models are too big. Okay. So let's talk about Google Colabs for a second. So anybody that's used a Colab environment, and I will just pull one up, what you'll see is you have a choice of runtime. So you can see that by, if we go to change runtime, there's a choice here. So you get the T4, A100, V100, and so on. So right now, I can't even get access to the A100 or the V100, but that's the usual runtime I would use. Let me see if I can do it in another session. Maybe it's just that one. Let's just have a look. So if I want to change the runtime type, that's why I have 0 compute units left. That's why I can't get access to the runtime. But essentially, you have an option of 3 different types of GPU, the T4, the A100, and the V100. Of these, the A100 carries the highest memory. And if I could get access to runtime, I'd show you. But essentially, you can get up to 80 gig with the A100. Now, anyone that's used Colabs, you know straight away that this is not always available to you. It's literally, if you can get the resource allocated, you'd be lucky, but you can get up to 80 gig. Usually what you're stuck with Colabs is approximately about 12 or 13 gig. I think it's about 12 gig of memory. And you'll get a V100. So at that 12 gig, you are not running a Llama 70 billion parameter model within Colabs. You're not even loading that. And even if you went down to 8-bit, you wouldn't load it. And even if you went down to 4-bit, you wouldn't load it. So Colabs becomes quickly limited in that sense. You won't be able to run these models in Colab. Okay. So we'll do some quick math here. To load a model in Colab, if you did get the 80 gig, you could load in 8-bit. You could load in 8-bit, but you couldn't fine tune and train. If you wanted to fine tune in Colab, you would need, so let's say if you wanted to fine tune in Colab, right? So let's say, you would need, at full precision, let's say if you wanted to fine tune at full precision, you would need at least 8 A100 GPUs. Apologies. So let's just do the math here. Let's do the math. So we know we need 630 and we can get A100s up to 80. Yeah. So if you wanted to fine tune not at the 32-bit, just at the 8-bit precision, so loading the model at 8-bit precision, you would need almost 8 A100 GPUs, which is just unreasonable for most hobbyists, unreasonable for most researchers, most engineers, even most companies. Most startups probably aren't going to invest in 8 GPUs up front. And yeah, it's a massive barrier to entry. It's a huge hurdle to entry. Essentially, you're left playing with the lower parameter versions of the model, which obviously they can't match anywhere near the performance of the proprietary models from OpenAI or from Anthropic or from Google. So there's no chance really in that sense. And by the way, if you wanted to purchase an NVIDIA A100 for yourself, I think that could set you back over £12,000. It's a lot of money just purchasing the one. All right, so are there any alternatives? So this is where it gets interesting. There is actually an open source project out now, and I'm going to pull up the research paper for this project. It's pretty interesting. There's an open source project out now called Petals. And you can see the title of this paper, Collaborative Inference and Fine-Tuning of Large Language Models. Let's talk a little bit about Petals and what it does. So it's a client-server architecture. And as somebody wanting to utilize a large language model, obviously you are the client. The servers are publicly hosted machines that have GPUs. So effectively, you can be a client, you can be a server, or you can be both. So the way you become a server is to run some code in your command line that they give you. So the Petals framework or the project has created some code. You can run that in your command line, and you are effectively allocating part of your GPU to the Petals network, which they refer to as a swarm or a public swarm of servers. Right. So how does this help us use some of those larger language models? So the huge ones, 70 billion parameters plus. Essentially, when you look at the architecture of these large language models, they are in layers, right? They were talking about transformer architectures here. These models are broken out by layers and stored across those public swarms. So each server in that public swarm, or each machine in that public swarm, carries some level of, or some number of consecutive layers or blocks of that transformer architecture, and it's all allocated based on the available memory for each public server. As the client, you only store the embedding layer. So that's how it works and I think you store the head and the embedding layer. You'll have to forgive me on that, but just double check the paper. But you don't, essentially it's the model is distributed across the swarm of networks. So it reduces the GPU load for you as the client massively. Okay. So how does inference work? Inference works by first finding the chain. So I'll go down and get a diagram for you, because there is actually a diagram that helps illustrate this a bit better. So you can see here, there's different layers of, they've illustrated this with Bloom, and there's different layers of the Bloom architecture stored across different machines these are all GPUs. And I like the way they've done it, because you can see they're kind of all different specs and different memory, but these are the servers that host layers of the Bloom model in this public swarm. Okay. So as a client, if you're trying to do inference, so let's say you want to test out, or you want to build an application on top of Llama 2, the 70 billion parameter. If you were to go through Petals, you can send a request or an inference request through the 70 billion parameter model. And what Petals does is it finds a chain of servers that collectively hold all of the models. So not every server is going to be online or active all the time. Sometimes the memory, the GPU memory is completely consumed with other processes. For example, somebody could be running their own deep learning workload, or they could be playing a game, so their GPU is maxed out, right? So it needs to find a chain of servers that can collectively hold all the layers and are active, right? The client stores the embedding layer locally, so you have that locally on your machine. You still need some memory to be able to allocate to that. Once the embeddings are generated on the client side, they are sent to the servers, which process them through consecutive layers. The servers then send the new representations back to the client, who then uses those for predicting the next token. So essentially, the normal operation of your transformer, the feed forward process, or the forward pass through the network through the transformer network, is distributed across various different servers. That's how Bloom have solved this, or are trying to solve this problem of large language models being too big to run any inference locally. Okay. What do they quote here? So they quote that, I just want to, system requirements. Yeah, so for Bloom, which is a 176 billion parameter, inference clients need at least 12 gig of RAM, and most of that is just to store the embedding parameters, which is about 3.6 billion to make this work. So you need about 12 gig of RAM. But let's just think back to what we were saying about Llama 2, right? So we said at 8-bit precision, we need 70 gig of RAM, 70 gig just to load Llama 2. So you can see this is Bloom, which is much bigger. It's 100 billion parameters larger than Llama 2. And we've reduced that workload down to just 12 gig of RAM. It really does sound promising. It sounds promising. And there are claims in this paper as well that the speed here it's fast enough for application use cases. So there isn't a lag in inference time because you're working across a distributed network. That's what they claim. Now, there are definitely some things to be concerned about if you are going to use Petals and if you're going to build applications on top of it. The first one is the project doesn't seem to have gotten a lot of traction yet. And I'll illustrate this. So you can go into the Petals health check. If I zoom out just a little bit, hopefully you can all see this on the screen. But have a look at this, right? So this is the swarm for Llama 2. So these are all the server IDs. We can see them here. And you'll notice that there aren't that many. We've got 5 server IDs. And you can see when they're offline, online. So where those green dots are, they've been online, and there's a key down here. So those are the ones that are up and running, right? Now, obviously, with only 5 servers supporting the Llama 2, it's quite difficult to get this thing to work. I tried to run an inference job earlier and I was getting some issues. I was getting some memory issues, and I don't think the network was able to allocate enough memory to the job, just because there just aren't enough servers online yet. So that's one issue you're going to face if you try to use Petals as is today. Another issue is the documentation. Now, obviously, Petals is not a mature project yet. So let's just go to the GitHub just to give you an illustration of what that looks like. So this is pretty much it in terms of documentation. Now, granted, to their credit, right, they have supplied some collabs that you can get your hands on to try out the project. So this is one example. No, that's not it. Yeah, so here's an example. Here's one of the collabs that they provide, and they take you through various use cases. So I think there's one for inference here with Llama 2, and there's one I think there's another for fine-tuning as well that you can walk through. But the issue is that even with these collabs, if you try to make it work, it's probably not going to work. I have not managed to get this Petals to work as of yet, even running through the collabs. So that gives you an indication that, the resource just isn't there yet. And if anybody has used Petals and gotten it to work, I'd love to have a conversation with you, or just to see how you did it. So that's on documentation. They do provide some collabs, but the documentation isn't extensive at all. You pretty much got the collabs and this README, and that's it. And I found it quite difficult to debug what's happening under the hood with Petals as well. So it is really early. It is super early. They do provide a Discord channel. So the Discord channel is pretty helpful, and they are responsive. I would say as the user base grows, if the network doesn't grow at the same time. So if you just have clients with no server, so if the client side grows but the server side doesn't grow, then it's not going to be a very useful network, obviously. I think they are looking at ways to try and incentivize people to join the network. And there's obvious things there about people not wanting to allocate their memory to a network that they have essentially no control over. I think, trying to incentivize people to join that is going to be a tough challenge. One thing I've heard mentioned is the idea of remunerating people in compute units. So essentially, if you are a part of the network, if you're providing a service, if you're a server in the network, then you get priority over compute that is shared across the network. And maybe that's proportional to the amount of memory that you contribute to the network. Maybe it's something like that, or something along those lines. And you can even tokenize that in terms of some kind of digital currency as well. So I've heard that mentioned before. The last thing to consider here before you decide to jump onto Petals is privacy. And to their credit, the authors of the paper do mention this, right? There are real privacy concerns here, because essentially the servers that hold the first layers of the network can reverse engineer those and get back to the input embeddings, which means they could probably decode those to get access to your data. So if you are dealing with any sensitive data, you should not be sending that to a public swarm on Petals. And I think they mention that explicitly here with privacy. Yeah. So an important limitation of our approach is that peers serving the first layers of the model can use their inputs to recover input tokens. Yeah, so if you're working with sensitive data, you do not want to be using a Petals public swarm. That is going to be pretty dangerous for data leakage purposes. Now, they do mention that you can set up a private swarm, which means you have control over every server in that network. But at that point, I can't really see the benefit of doing that, as opposed to just setting something up on cloud. I really don't see the benefit if you're just going to set up a private swarm. So there is that to consider as well. I don't know if it's easier to do it via Petals or cloud. I haven't done either, so I don't know. And that is pretty much it in terms of Petals. I think check it out for yourself. If you can get it to work for you, it would be great if you could comment under this video about how you did it or how you found the experience. I am part of the Discord channel, so it'd be great. You can even talk over the Discord channel if it's easier to talk details. I would love to try and get this thing to work at some point, and if I do get it to work, I'll be doing a video on that, obviously, to show you the steps. I think it's a promising project. I think, the fact that they're trying to democratize access to these large language models is brilliant, and it's a much needed area. There's a lot of papers coming out right now that are really interesting, but they are obviously limited to exploring on the smaller models, and it would be interesting to see how their findings extrapolate out to those larger language models. So that is going to obviously be a step in the right direction if Petals gets to a point where it is feasible for many of us to start using regularly. Thanks for listening. I hope that this was informative, and I hope that it gives you a better understanding of why you can't use Llama 2 yet, but maybe there is something on the horizon that will allow you to use it in Petals. Please like the video, please share, please subscribe to the channel. We do also offer data science and AI consultancy through Data-Centric Solutions. So if you need consultancy, if you need AI products developed, if you need applications built, please register a session with me through the link in the description. The session is free, and it's a scoping session just to understand what you would like to do, the direction you like to head in terms of artificial intelligence or data science, and how we can proceed from there. So please visit the link if you do need AI or data science consultancy. The specialism right now is large language models and automating document processing. So anything along those lines, we will be happy to help you with. Thanks for tuning in once again, and until the next time.